Okay, so we will do a sound check. 1 second. One, two, three. One, two, three. Okay. So I'll go and turn off the speakers and close the YouTube so there will not be feedback. So I'll go and turn off the speakers and close the YouTube so there will not. Okay. So, hi everybody. I'm Nir Strulovitz, the prophet of AI, and today we are doing another lecture. I'm trying to do 2 episodes in each day. So today this is the 2nd episode, and in total it is the 8th episode, and its title is Edge Computing, Paradigm Shift, or Niche Trend. Okay, so maybe it's like a big thing, maybe it's like a small thing. Okay, so I'll write it down. Again, I'm using the electricity like all the time, so I'm wired. So that the battery will not run off, so that I can do 2 broadcasts in each day, and I hope that I will be enough recharged. I drank like chocolate milk and ate cookies, and I hope I will have energy to stand and talk for another like 4 hours or something. Okay, so we will see. It's an experiment. Okay, so let me write down the subject: edge computing. Paradigm shift. Or niche trend. Okay. So to those of you who do not know what edge computing means, it's like back in the old days, there was like a big computer and small screens. Okay, it was like a mainframe and terminals, and the terminals were just like the screen and keyboard without brain. Then later it became that the personal computer got stronger and smarter, and it was more equal. The server was like the mainstream, the mainframe, and but it was not so stronger than the client, which was the PC, personal computer. So it was server client, but more balanced, not like mainframe and terminal. It was more like server, a little bit better than the client. And then after this, it was again cloud, which is like a farm of servers, which is very strong, compared to a PC, like the edge client, which is weak, okay, comparatively, even if it's a gaming PC like mine, but it is compared to the big server of, let's say, ChatGPT or any other big company, it's very small. And now they want to do it a little bit balanced again, like with edge computing, which means computing things not in the big faraway cloud, but like more like in the closer fog, like closer to the client. Maybe a few clients together have edge users like me and you and small people have close to them, physically close, some local center. Okay, I don't know how to call it, but it's like a server, but it's very close to them. So like, for example, if you have all the smart devices like Internet of Things, so they don't each one of them call from, I don't know, from Israel, the USA. So they like connect to something which is much closer, and they get the information. And also they might get like, okay, you ran out of milk in the fridge, let's say, and the local supermarket has this milk that you like. Okay, so you don't need to call the USA to just to know that if everything is local, then you make this edge computing is like doing this locally. Okay, so not every little gadget in your home needs to call the other side of the world. We can do the calculation locally. So this is edge computing if you don't know what it is, because I didn't know what it is, so it's okay. Okay, so paradigm shift or niche trend. I think the only word that you might not know is niche. Niche is like something very narrow and specialized, as opposed to a paradigm shift, which is like the paradigm is what everything relies on. It is the convention of everything. So is it wide and big, or is it small and for only special uses? Okay. So ChatGPT, I will try to do it faster than usual. Sorry, again, because it is I want in each day to make two lectures. So I want to make it faster. So ChatGPT, it's written because the AI that wrote this report is ChatGPT 5.1 Pro in deep research mode. Okay. Topic restatement. The question at hand is, can you hear me? 1, 2, 3. Yes. Okay. Topic restatement. The question at hand is essentially putting edge computing on trial. Is it genuine paradigm shift poised to challenge or even overtake cloud computing? Or will it remain a limited niche technology that complements but never surpasses the dominant cloud model? In other words, will processing data at the edge on devices or local nodes closer to the users become the next major tech revolution? Or is it an overhyped trend confined to a few specialized use cases alongside the cloud? Assumptions and approach. I'm proceeding under the assumption that our audience consists of tech-savvy retail investors, startup founders, and small family office investors. They care about business and investing implications. Now, I'll just tell you in 2 words that I think it is a gimmick, and like the majority will stay in the cloud from the simple reason that first of all, the cloud has much more power, but more importantly even, the need for the companies and the governments to spy on what are you doing and to predict what you are doing from the very small things. If you miss all these things, then you cannot get this information. Okay, so in my study, like when I studied law in the university, my profession is like a lawyer, so I don't work in this, but this is my profession. So it was called, I don't know how it is in English, but in Hebrew it's like a seminarionic work. Okay, it's like you write some like small thesis on something, like 30 pages. So mine was about privacy and how to like technologically protect the privacy of people. Like now it's very obvious, but back then, like 20 years ago, it wasn't obvious. So all kinds of methods how to technologically protect the people. Of course, none of this was implemented, and because all the insurance companies and all the like companies that want to sell you stuff and manipulate you, they want to know all about you. So basically, I will not give you the whole laydown of what I wrote, but it's a very, very important and big business for them, and it allows them to know exactly what is your condition, your health condition, your mental condition, like almost what you think based on the small decisions that you do. So they do want to know everything, like where you are, what you eat, what happened to the milk in the fridge. They do not want it to end in, I don't know, in your neighborhood server. Okay? So I don't think it will be much more than a niche. But again, let's read what ChatGPT says. He will not have this argument, I guess, which is the main argument. But who knows? Okay. So in other words, will processing data at the edge on devices or local nodes closer to users become the next major tech revolution, or is it an overhyped trend confined to a few special use cases alongside the cloud? Assumptions and approach. I'm proceeding under the assumption that our audience consists of tech-savvy retail investors, startup founders, and small family office investors. They care about business and investment implications of technology over roughly the next 0 to 5 years, short to mid-term. Though we'll touch on longer-term outlook if they impact current decisions. The focus is global, primarily North America and Europe, the global north, but considering opportunities and trends in Asia, China, India, etc., etc., and everywhere, and elsewhere as well. The goal is to inform on where money might be made or lost as edge computing evolves, not just the technology itself in isolation. I will make sure to incorporate the regional market leadership and growth points you provided, like me. For example, the roles of the US, China, Europe, Asia Pacific, and cover a wide range of edge computing use cases, industrial IoT, Internet of Things, smart cities, retail, healthcare, etc. evenly, without over-focusing on autonomous vehicles, since you have already explored that in depth before. Okay, we had another episode on smart cars and stuff, like autonomous vehicles. Before. I will only mention vehicles briefly as one of many examples unique to Edge. I will also avoid fleeting private market, although it's like useful for Edge because theoretically if you are in some place, some area, because your car took you there, then you need to know like what is the businesses locally, what is the special prices or discounts in this gas station, in this restaurant, in this hotel. So it is interesting, but I didn't want it to be all about cars. So this is why I told him not to focus on cars. I will only mention vehicles briefly as one of many examples unique to Edge. I will also avoid fleeting private market VC venture capital trend gossip, so the report remains relevant for months. All analysis will be backed by up-to-date 2023 to 2025 sources, and I will explicitly tie arguments to economic and investment stakes. No further clarifications needed. I have your guidance on regions and use cases. I will now dive into the full structured report as requested. Okay, so now a big headline: Edge computing, paradigm shift or niche trend. Overview. Edge computing, processing data on devices or local servers closer to users instead of in centralized clouds, has emerged as a hot tech topic. Proponents hail it as a paradigm shift that could reshape industries by enabling ultra-low latency services, powering the Internet of Things IoT, and addressing data privacy concerns. Skeptics, however, see it as mostly niche, useful for specific real-time applications, but unlikely to overtake the massive role of cloud computing. For investors and businesses, what's at stake is significant. If edge computing truly takes off, it could redistribute the economic balance of power in tech, benefiting telecom operators, semiconductor firms, and new edge service providers. Or conversely, if it stays limited, the status quo of cloud giants like Amazon, Microsoft, and Google will remain largely unchallenged. This report examines both sides of the debate, weighing the evidence on whether edge computing is the next big revolution or just a complementary trend, and delivers a verdict with investment implications. Disclaimer: this is educational analysis, not financial advice. Okay, as usual, I am not a financial advisor. this is not education. This is not financial advice. Not. I'm not qualified to give financial advice. I'm not giving financial advice, and so on. You can see in the website the disclaimer at the bottom. Okay, so very short background. Okay, title, headline, very short background. Edge computing refers to a distributed computing model that brings computation and data storage physically closer to the data sources and end users. Instead of sending all data to a centralized cloud data center, some processing is done on local devices, routers, or micro data centers at the edge of the network. The basic idea isn't entirely new. Content delivery networks, CDNs, have cached data near users since the 1990s. But in the 2020s, the concept has greatly expanded. The rise of the Internet of Things, IoT, billions with a B, billions of sensors and smart devices generating data, and the rollout of 5G networks, fifth generation networks, have made edge architectures more critical because transmitting huge volumes of data to the cloud can be impractical due to latency and bandwidth limits. By processing data on site or nearby, edge computing can reduce network loads and provide faster response times for time-sensitive applications. Today, in 2025, edge computing sits at an interesting juncture. On one hand, cloud computing still dominates IT. Enterprises globally will spend over 595 billion with a B, so almost 600 billion with a B dollars on public cloud services in 2024, and more than 720 billion dollars with a B in 2025. Whereas edge computing investments, while growing fast, are smaller, in the low hundreds of billions with a B. All major cloud providers have actually embraced edge in hybrid forms. For example, Amazon's AWS offers Outposts and Wavelength. Oh, I didn't know like that the same companies, the cloud is making it, so it's actually, they are still spying on you. So obviously then they are okay with it. Their main point is to spy on you. Giving you some service is just like a bonus. But if they are the ones who are doing the smaller cloud, then of course they are still spying on you, so it's okay with them. So I take it back that it will not succeed if they are doing it themselves. Okay. All major cloud providers have actually embraced edge in hybrid forms. For example, Amazon's AWS offers Outposts and Wavelength for on-premise in the place and telecom edge integration. Microsoft Azure has IoT Edge and Stack Edge. Google Cloud has its Anthos for Edge and the Mobile Edge Cloud partnership with Telcos. These indicate that rather than a pure cloud versus edge showdown, the industry is heading toward cloud edge convergence. On the other hand, many technologists and analysts argue we are entering a new era where computing will be far more decentralized. Gartner famously predicted that by 2025, 75% of enterprise data will be created and processed outside of traditional centralized data centers or cloud environments. A dramatic jump from only about 10% today. This reflects the massive expected growth of edge devices and local processing from factory machines and retail sensors to autonomous vehicles and smart city infrastructure. Geographically, the edge computing race is led by the United States and China. The US, home to the biggest cloud and semiconductor companies, currently dominates edge spending. North America accounts for over 40% of global edge investments. US tech giants, Amazon, Microsoft, Google, IBM, etc., are heavily investing in edge R&D and deployment, driven by high demand for low latency applications in industries like healthcare. For example, remote monitoring, manufacturing, industrial automation, and transportation, autonomous and connected vehicles. China, meanwhile, has become a hotbed of edge innovation. In China, it's even more important to spy on you. No, but it's equal to the US. Just the US is a hypocrite, and China is it's clear that they are spying on you. A hotbed of edge innovation, fueled by its rapid fifth-generation rollout and government-backed initiatives in smart infrastructure. In fact, 7 out of the top 10 organizations filing edge computing patents in recent years are Chinese. State-owned enterprises like State Grid Corp, China's electric utility, lead in patents, 400 plus filings, reflecting China's push in smart grids and IoT, Internet of Things. And Chinese telcos plus tech firms like Huawei, Tencent, Alibaba are deploying large-scale edge networks. Asia Pacific more broadly is the fastest growing edge market, with countries like India ramping up digital infrastructure. For example, India's Digital India program, and Southeast Asian nations adopting edge for smart cities and telecom. Urbanization and smartphone penetration are creating huge volumes of local data that edge computing can handle. Europe is also a key region experiencing steady edge growth, particularly in Germany, the UK, France, and the Nordics. European industries are integrating edge in Industry 4.0, manufacturing and city services, and strict data privacy laws like GDPR provide an extra push for on-premises or local processing, so that sensitive personal data doesn't always need to leave the country. In short, edge computing has captured worldwide attention, investors care because it could shift who profits from the next wave of IT spending. Will cloud providers extend their empire to the edge? Will telecom and hardware companies seize new revenue? Or will much hyped startups fizzle out? Understanding the reality versus the hype is critical for any tech-forward business strategy. Okay, visual aid, even though I always tell him not to do it. Visual aid, an illustration of edge computing architecture with devices at the bottom, edge nodes in the middle, and the cloud at the top. Okay, I cannot make any heads or tails of it, so probably you couldn't too, but here, this is what he drew. So a cloud is on top, there are small clouds in the middle, and there are devices in the bottom. And the cylinder is like the database, but it's connected to the cloud. In essence, you see why I always tell him never to use graphics. In essence, edge computing inserts a local processing layer between end-user devices, okay, the bottom of the drawing, and the cloud, the top of the drawing. Handling tasks like service delivery, IoT, Internet of Things, data management, caching, and initial analytics closer to where data is produced. This reduces the amount of raw data sent up to the cloud and can significantly cut down latency. Okay, now a headline. What is not in dispute? Common ground. Before diving into the contentious points, it's worth noting several key facts about edge computing that both proponents and skeptics generally agree on. Now it's bullet points. I will read them one by one. Latency and local processing. Edge computing's core advantage is reduced latency. By processing data near its source, it enables faster response time than routing everything to a distant cloud. For use cases like real-time machine control, or augmented reality, this local processing is essential and universally acknowledged as valuable. Next point, cloud current dominance. No one disputes that as of mid-2020s, cloud computing remains the dominant paradigm in IT. Enterprises continue to pour hundreds of billions with a B into cloud services annually, whereas edge deployments, though growing, are a fraction of that. The vast majority of computing workloads still run in centralized servers or cloud data centers today. Okay, next point, a growth of data and IoT driving edge. Both sides recognize that the explosion of IoT devices and data is a driving force for edge adoption. Okay, IoT, Internet of Things, is always on edge, okay, computing, because it's small devices. You cannot have each device send all the data to the other side of the globe. Okay, so again, growth of data and IoT driving edge. Both sides recognize that the explosion of IoT devices and data is a driving force for edge adoption. billions with a B, billions of sensors, cameras, and gadgets generate massive data streams. And sending all that to the cloud is inefficient and impractical. The rollout of 5G, the fifth generation, networks with much higher speeds and device densities is another catalyst. 5G, fifth generation, makes edge architectures more feasible and necessary, especially in China and the US, where carriers are integrating computing at cell towers. Okay, so the cellular communication, like the cell phone company, makes computation, like maybe with some big company of the cloud, so like a mini cloud in the local place. So they still have the spy on you thing, so it's okay with them. Next point, key industries and use cases identified. It's commonly accepted that industries like manufacturing, logistics, energy, telecommunications, retail, and healthcare are moving the earliest and strongest, are among the earliest and strongest adopters of edge computing. These are sectors where real-time decision-making and local autonomy provides clear benefits. For example, factory equipment using edge AI for instant, immediate quality control. Telecom networks using multi-access edge computing, MEC, multi-access edge computing, to deliver ultra-fast video or game streaming. Retail stores running on site analytics, retail stores running on-site analytics for shelf inventory or checkout. Hospitals processing sensitive patient data locally for privacy. Even autonomous vehicles and drones, often cited in edge discussions, fit this pattern. They rely on on-board or roadside edge computing for split-second sensor processing, since a cloud round trip would be too slow. Okay, I understand why, because the car is driving, and by the time that the answer will get back, it will come back to the wrong cell tower or the wrong local internet point. Both optimists and skeptics agree these are logical use cases. The debate is how widespread such applications will become. Okay, next point. Hybrid cloud edge architectures are emerging. It's agreed that in practice, most companies deploying edge are doing so in tandem with cloud, a hybrid model. Surveys show a hybrid cloud edge approach is common. Around 36% of organizations use a mix of both. The edge often handles part of the workload, for example, initial data filtering or quick local actions, and then communications with the cloud for heavier processing or storage. This implies cloud and edge are complementary in many current implementations. Next point, global investment is rising. Both sides acknowledge that spending on edge computing is growing rapidly in the mid-2020s. IDC estimates global edge investments at about 232 billion with a B, billion dollars in 2024, up about 15%, 15% from 2023, and projecting 350 billion with a B, billion dollars by 2027. Dozens of vendors, from chip makers to software firms to telecom operators, are pouring R&D money into edge solutions. This trend is not really in dispute. The question is more about outcomes. Does this investment yield a new dominant paradigm or just incremental improvements? Next point, United States and China lead the charge. It's accepted that North America, especially the US, holds the largest market share of edge computing adoption today. Roughly 40%, 40% plus of global edge spending, followed by Western Europe and China. China in particular is recognized for its aggressive edge computing push via 5G, fifth generation, smart grid projects, and numerous patents. Both sides agree these two superpowers are setting the pace in edge development, while other regions, European Union, India, etc., are accelerating as well. Next point, data privacy and sovereignty concerns. In a world of increasing data regulation, GDPR in Europe, data localization laws in India and China, or China, etc., India/China, etc., etc., there is common ground that keeping data local at the edge can help compliance. By processing and storing sensitive data near its origin, for example, on a factory site or within national borders, organizations can better meet regulations that strict sending personal data abroad. This is a factor driving interest in edge strategies in regulated industries and regions. Okay, so these are all the bullet points. Now, normal text. These points form the factual background accepted by both the prosecution and the defense in our debate. Now let's hear each side's case. I just have to say that I didn't know it is such a big thing, and if it's the same companies that do it, they are the same companies that do the cloud, then it's like making sense, because they still spy on you and get all the benefits of spying, but without all the being flooded by all your information, your useless information. They just take the part that they want. Okay. Now a headline, side A, the niche trend, prosecution, the skeptics. Okay, it's this side, the skeptics that say it is a niche. Okay, so it will remain a niche. So now I no longer think it will remain a niche, but I will just bring the chair so I will be more comfortable. I'll just go to the bathroom 1 second and I'll come back. sorry. One, two, okay. Okay, so side A, the niche trend prosecution, the skeptics, those who think that it will be just a niche. So now I don't think it will be a niche, okay? I think it will be big, because I understand it is made by the same companies. The skeptical view, our prosecution, argues that while edge computing has its uses, it will not overtake cloud computing as the dominant model. This side sees edge as a useful but limited niche that will remain subordinate or complementary to the cloud. Key arguments from the skeptics include, now it's bullet points, I will read them one by one. Slow and limited adoption so far. The prosecution points out that despite years of buzz, edge computing's adoption remains cautious and uneven. Many enterprises are still just experimenting. In a 2025 industry survey, 55% of IT professionals admitted they are only somewhat familiar with the concept of edge computing, indicating that understanding and expertise are not yet widespread. Additionally, a significant portion of companies currently allocate only trivial parts of their IT budget to edge initiatives. 21% of firms spend less than 5% of IT budget on edge, and only about 1/3 spend over 10%. In other words, for most organizations, edge is still a side project, not the core of their IT strategy or spending. This suggests that real-world deployment is lagging behind the hype. The most advanced uses like AI/ML, machine learning, inference at the edge or smart city infrastructure remain less widespread, largely confined to pilot projects. Next one, edge use cases are niche and specialized. Skeptics argue that truly compelling edge computing use cases exist, but they are relatively narrow in scope. Ultra-low latency or local processing is mission critical in some scenarios. For example, self-driving car navigation like AR/VR, augmented reality, or like with the simple glasses, or virtual reality with the headset, which is bigger, interactions, real-time machine control on a factory floor. But how many applications truly need sub-10 millisecond latency or absolute data locality? I don't think it's so much this, it's just that they want to spy on you with every gadget that you have, like even the buttons of your jacket if it's possible. And this is why they will push it. They want the whole picture of you in every second. For the vast majority of business applications, from web apps to enterprise software, analytics, etc., cloud data centers suffice. The prosecution notes that, okay, the prosecution, those that think it will be small, notes that even in IoT, Internet of Things, much of the data doesn't require instant processing. Sensor readings can often be batch uploaded to the cloud for analysis. They also point out that some often cited edge scenarios like fully autonomous vehicles or ubiquitous AR glasses, augmented reality glasses, are still not mainstream reality in 2025. The technology and regulatory environment for self-driving cars, for example, is still maturing. So betting on a massive edge build out for them may be premature. Yes, we have remote surveillance cameras and retail sensors doing some on-site computation, but these are incremental improvements on existing systems. For example, CCTV, closed-circuit television cameras, with local DVRs is not exactly a revolution. The bottom line, outside of a few specialized domains, edge computing's benefits don't justify the added complexity and cost. Next point, economies of scale favor the cloud. One of cloud computing's strongest advantages has been economies of scale and centralization. You can operate massive data centers very efficiently, sharing computing resources among thousands of customers. The skeptics argue that moving to many distributed edge nodes sacrifices some of these efficiency gains. Edge infrastructure can be expensive, both to deploy and maintain. You need hardware in many locations, often harsh or remote environments, backup power and physical security for each, and local IT management. The cloud, by contrast, concentrates resources in a few strategic locations with professional staff and robust facilities. Unless absolutely required, why would a company want to maintain potentially dozens or hundreds of mini data centers at the edge? The cost per unit compute might be higher at the edge due to smaller scale. In fact, a recent study highlighted that cost is the single most significant barrier to edge computing adoption for enterprises. Companies have to buy and install edge devices/servers, whereas cloud services are pay-as-you-go. Unless edge delivers clear revenue or savings, CFOs, Chief Financial Officers, will be hesitant to bankroll a widespread edge rollout. Next point, management complexity and fragmentation. Relatedly, the prosecution emphasizes the operational complexity of edge computing. By distributing computing across many sites, you introduce challenges in management, consistency, and security. Enterprises already struggle to manage multi-cloud environments. Adding edge nodes multiplies the complexity. An industry analysis by STL Partners noted that the edge/IoT ecosystem remains highly fragmented, with disconnected technologies, incompatible platforms, and uncertainty about where to invest, which in turn slows adoption and limits progress. In essence, there is no single dominant edge platform. Companies must patch together solutions, potentially different hardware, software, and vendors for IoT, Internet of Things devices, edge servers, connectivity, etc. Yes, but soon like the AI will be the operating system, so I don't see it like it will not be complicated for the AI to control every node and integrate. This fragmentation can deter all but the most committed or resource-rich organizations. As a result, many businesses might stick to the simplicity of central cloud deployments rather than take on the headache of edge orchestration. The skeptics also point out a shortage of skilled talent in edge computing. While cloud DevOps has matured, expertise in edge deployment, which may involve networking, embedded systems, and specialized AI hardware, is harder to find. Again, it's not relevant at all because the expertise will come from the AI itself inside the system. Okay. Next point, security risks at the edge. The cautionary side raises concerns that spreading computing across myriad edge devices increases the attack surface for security breaches. A cloud data center can be secured and monitored by a top-notch team. But what about thousands of edge nodes in the field? Each could be a point of entry for hackers if not properly secured. Maintaining consistent security updates and patches on widely distributed devices is non-trivial. If an edge device is physically accessible, for example, an IoT hub in a remote facility, it could even be tampered with. Thus, I'm just moving the mouse because the screen went black. 1 second. Oh, I forgot I have okay. I got the mouse. So it's similar to the Internet of Things. I have another mouse close to me. Okay. So it's an edge mouse. Okay, security risks at the edge. The cautionary side raises concerns that spreading computing across myriad edge devices increases the attack surface for security breaches. A cloud data center can be secured and monitored by a top-notch team. But what about thousands of edge nodes in the field? Each could be a point of entry for hackers if not properly secured. Maintaining consistent security updates and patches on widely distributed devices is non-trivial. If an edge device is physically accessible, for example, an IoT hub in a remote facility, it could even be tampered with. Thus, some organizations might actually prefer the centralized security model of cloud, especially for sensitive workloads. Proponents counter that edge can improve security by isolating data, but the prosecution is unconvinced. In their view, more nodes equals more potential vulnerabilities unless managed perfectly. Okay, next point. Cloud isn't standing still. Another key argument, the cloud giants are not ignorant of these needs. They are adapting. The skeptics note that whatever edge can do, cloud providers are extending their services to cover it. For example, if ultra-low latency is needed, major cloud providers now offer regional local zones and edge servers like AWS local zones or Azure edge zones, essentially bringing the cloud closer to you. For on-premises needs, AWS Outposts or Azure Stack let customers run mini cloud environments locally. So instead of independent edge upstarts overthrowing the cloud incorporates edge into its own ecosystem. Well, of course, this is the main thing, like what the big companies would like to happen. Like if for them it's easier to spy on you with a real edge system or like infrastructure, then this is what will happen. If the big companies prefer to make it half edge, then this is what will happen. It's all depending on this, how they prefer to spy on you. This means the edge revolution could be co-opted by existing players. And we don't see a big shift in the landscape of who profits. It will still be Amazon selling you gear just for your factory floor. Additionally, improving network technology, for example, widespread fiber and future 6G, sixth generation, could further reduce latency from devices to cloud, eroding some advantages of processing right on the device. Skeptics often quote experts who say edge will never fully replace cloud. Edge will never fully replace cloud. For instance, one industry veteran stated, quote, edge computing will take its place as another option, but it's not going to ever overtake cloud data centers because there are lots of things you can't do in an edge data center. Cloud data centers have virtually limitless compute power, which edge nodes can't match. The prosecution underscores that for big data crunching, AI model training, and global scale analytics, the cloud or centralized on-premises data centers remain irreplaceable. Yes, of course, it's for the big, like if you ask the model, the AI, and you want the best answer, of course, it will only be in the cloud. Except if it can connect a lot of small computers into a big supercomputer on the fly, but it's like a lot harder. It's easier on the cloud. Okay, next point. Historical precedent. The swing back to centralization. The skeptics also put the trend in historical context. Computing paradigms tend to swing like a pendulum, from centralized mainframes to decentralized PCs, and back to centralized cloud. We talked about this. I didn't know about it, but it reminded me also of this. Right now, edge computing is essentially a form of decentralized computing. The prosecution argues that we have seen many decentralization, okay, spreading, decentralization, that it is not one center, but many small centers. Decentralization fads before. Remember the excitement around peer-to-peer computing or even just client-server models. But ultimately, the economic and management efficiencies of centralization reassert themselves. Edge computing, in their view, might flourish in the margins, but the center of gravity will remain in the cloud. It's telling that even companies that tried to go full edge often still end up sending a lot of data to cloud for aggregation. A common saying is, a common saying in this camp is, the edge is just tomorrow's on-premises data center. We have had an on-premises servers. We have had on-prem servers for decades. Edge is a rebranding with better wireless and AI chips, but it doesn't fundamentally change the game the way proponents claim. Okay, next point, investor caution. Uncertain ROI, return on investment. From an investment perspective, the cautious side notes that many edge computing startups and projects have struggled to articulate clear business models. Unlike cloud, which quickly showed cost advantages and scalability for customers, edge solutions often require heavy upfront investment in hardware integration, and the ROI, return on investment, Unlike cloud, which quickly showed cost advantages and scalability for customers, edge solutions often require heavy upfront investment in hardware integration, and the ROI, return on investment, can be murky unless there is a special problem being solved. The skeptics would cite that as of 2025, there haven't been many publicly traded pure-play edge computing success stories. Instead, most gains are accruing to established firms. NVIDIA selling chips, telcos selling connectivity, etc. For venture capitalists and investors, some parts of edge may be overhyped. For instance, if everyone is claiming their IoT device does edge AI, it could become a buzzword without sustainable differentiation. The prosecution warns that investors chasing the edge trend could overpay for niche companies that will either remain small or get subsumed by bigger players. In short, they see a lot of risk of overvaluation in the edge startup space and recommend caution until more concrete revenue growth is demonstrated. So now these are all the bullet points. Now normal text, prosecution, conclusion. What do they say? If you believe the skeptics, you would conclude that edge computing is an important add-on for certain real-time and IoT scenarios, but not a paradigm shift that will dethrone the cloud. In 5 years, the typical enterprise might have a few edge deployments for specific needs, but the bulk of computing spend will still go to the cloud and centralized infrastructure. An investor taking this view would be cautious about overhyping edge, perhaps investing instead in the picks and shovels, chips, networks, rather than any edge platform revolution. This would worry, the investors, would worry about edge being a fragmented niche and potentially a money sink for companies that dive in without clear returns. Okay, now a headline, side B, the paradigm shift defense, the optimists. Okay, the people that say that this will be like a big thing. I will just get the chair out of here so I can walk back and forth. One moment. One, okay. Okay, so side B, the paradigm shift defense, the optimists. On the other side, we have the optimistic view, the defense, arguing that edge computing is a revolutionary shift that will become an essential, perhaps even dominant, part of the computing landscape. These proponents see edge as the next evolution of cloud, not just a sideshow. Their key points include, now we have bullet points. I will read them to you one by one. First one, the data deluge demands edge. I don't know what deluge means, but we will see. The defense starts by highlighting the sheer scale. So I guess deluge is like if you have a lot of something. The data deluge demands edge. The defense starts by highlighting the sheer scale of data being generated in the modern world and how unsustainable it is to funnel it all to centralized clouds. They cite Gartner's eye-opening prediction that by 2025, 3/4 of enterprise-generated data will be created and processed outside of traditional data centers or cloud. This statistic underscores a fundamental shift. Thanks to IoT sensors, Internet of Things, sensors, cameras, and user devices, data is increasingly born at the edge in factories, homes, vehicles, retail stores. And it's simply not efficient to ship all that raw information back to a distant cloud for processing. Doing so would incur huge bandwidth costs, slow response times, and possibly violate privacy laws. Edge computing offers a solution by processing data locally, extracting the useful insights, and only sending needed results to the cloud. This cuts down on costly data transfers. Indeed, companies are realizing they can save on cloud storage and bandwidth bills by filtering data on the edge. The defense echoes the observation that reliance on cloud alone has led to some cloud regret due to high costs and performance bottlenecks. Many enterprises have learned that blindly pushing everything to the cloud can be expensive. As a result, they are repatriating. I don't know what it means, repatriating certain workloads to on-prem and to edge environments for cost and control reasons. But we get the general idea. This strategic pivot is evidence that edge computing is becoming a necessity, not just nicety. Next point, real-time applications equals competitive edge. It's the same meaning. Competitive advantage. Edge proponents argue that in an increasingly digital and automated economy, milliseconds matter. The ability to react instantly to local events can confer a huge competitive advantage. They point to sectors where edge computing has already proven transformative. For example, in manufacturing, companies are using edge AI for predictive maintenance, analyzing machine sensor data in real time to predict failures before they happen. This edge-driven approach has been shown to minimize downtime and reduce maintenance costs by fixing issues proactively. Similarly, quality control can be done via edge cameras on the assembly line where they put together the product that detect defects immediately using computer vision models locally, rather than pulling products off for inspection later. These environments directly impact the bottom line with higher uptime and less waste. In the energy sector, as another example, edge computing enables smart grids to balance loads and detect faults in milliseconds. China has demonstrated this with 5G fifth generation connected grid equipment, which makes the power network more efficient and resilient. Retailers can use edge for instant personalization. For example, real-time analytics in stores to adjust digital signage or offer coupons to shoppers' phones based on where they linger. Sometimes that wouldn't work if analysis happened in a distant cloud minutes later. Healthcare is seeing edge that Healthcare is seeing edge-enabled improvements too. Wearable devices and hospital equipment with on-device AI can monitor vital signs continuously and alert doctors of anomalies in real time, potentially life-saving in critical care or remote patient monitoring. The defense argues that all these examples illustrate the broader point. Businesses that leverage edge computing can deliver faster, smarter services and will outcompete those that rely solely on cloud's slower, centralized model. In high-stakes settings, a mining site, an oil rig, an airport tarmac, having compute on-site, edge, rather than hundreds of miles away, cloud data center, can be the difference between a constrained problem and a disaster. The quiet revolution of edge is already underway in these domains as of 2024, and the defense see it only accelerating. Next point, edge plus AI equals a powerful combination. The optimists often talk about the synergy of edge computing with artificial intelligence and machine learning. Edge AI, running AI algorithms locally on devices, is a game changer. Thanks to advances in semiconductor tech, powerful GPUs, specialized AI chips like NPUs, etc., we can now deploy sophisticated models at the edge. This enables things like computer vision in real time, on security cameras, identifying intruders or safety hazards instantly. This is not true because like the local software, the local hardware that you have, like the power of the computer that you have is less strong than the computer that they have in the cloud. So it's not really true, it's not real time. Anybody would try to do things with local LLM or local image generation. It's not at all the same like the strong LLM and the strong image generation that you have in the cloud. So it's just not true. This enables things like computer vision in real time on security cameras, identifying intruders or safety hazards instantly, and natural language processing on devices. For example, voice assistants that process your speech on your phone rather than sending audio to the cloud. The defense notes that big tech companies are investing heavily here. Apple, for instance, designs its bionic chips to run AI on the iPhone itself for privacy and speed. And startups are building tiny AI accelerators for sensors. Edge AI unlocks use cases that cloud AI can't serve well due to latency or connectivity. For instance, a factory robot might use an edge AI model to detect a human stepping into its zone and stop immediately. A cloud-based vision system with even 100 millisecond delay could be too slow. Or consider autonomous drones used in agriculture or deliveries. They need to make navigation decisions on the fly without waiting for cloud instructions. Proponents highlight terms like blue-collar AI. referring to AI at the edge in gritty environments like factories or mines, where it's providing real, raw, and immediate benefits. Importantly, as more AI is pushed to the edge, it also alleviates some privacy concerns. For example, a home security camera that does AI processing on device can detect a face or incident without streaming video to the cloud until necessary, thus preserving privacy and reducing cloud costs. The defense thus frames edge computing as an essential enabler for the next wave of AI applications that need to be decentralized. Next point. Infrastructure, investment, and momentum. The bullish side points to the significant momentum in industry and infrastructure supporting edge. Global spending on edge is surging, not just in dollar terms, but in concrete deployments. By 2024, edge computing has truly broken out, according to analysts. IDC forecasts IDC forecast edge spending to continue growing double digits, reaching roughly $350 billion with a B dollars by 2027. Telecom companies are on board, incorporating edge computing into 5G, fifth generation, rollouts via multi-access edge computing nodes at cell towers and central offices. For example, Verizon, AT&T, China Mobile, etc. are all deploying edge servers to offer ultra-low latency services to enterprise customers. Cloud providers are extending outward. As noted, AWS, Azure, Google all have edge or hybrid offerings. An optimistic view is that this validates the edge trend rather than negates it. The defense also cites partnerships like the 2024 alliance of NTT Data and Schneider Electric to deliver integrated edge plus private 5G plus IoT solutions. Such partnerships show traditional IT and OT, operational technology, giants move to capitalize on edge computing opportunities. On the hardware front, there is an accelerating pipeline of devices purpose-built for edge. For example, ST Microelectronics and other chip makers releasing microcontrollers and system on chips optimized for edge AI and sensor integration. All these investments suggest that edge computing is not a transient fad. It's becoming part of the standard tech stack. More than 400 distinct edge use cases across industries have been identified by researchers, and new ones are emerging as imagination catches up with the technology. The defense position is that we are witnessing a fundamental architectural shift in computing akin to the move from on-premises to cloud a decade ago, except now it's from cloud to distributed edge plus cloud. Next point, hybrid and multi-cloud future. Edge as an essential layer. The optimistic camp doesn't necessarily claim that cloud will disappear. Rather, they envision a distributed future where edge plus cloud work together in a seamless continuum, often referred to as hybrid cloud edge or even fog computing as an intermediary layer. In this paradigm, edge computing is a paradigm shift in that computing becomes ubiquitous. Okay, it's in everywhere. Instead of a few giant, like it's very common, not if it's everywhere, it's omnipresent. Ubiquitous, it's like very common. Instead of few giant centralized clouds, compute power will be embedded everywhere, in every building, every vehicle, every city block, almost like how electric power becomes distributed to every home and device. The defense argues that this is a natural evolution as society demands more real-time responsiveness and reliability. So, if one cloud region goes down, operations that have local edge capabilities can continue. Edge adds resilience. Gartner has stated that edge will complement cloud for nearly every enterprise by 2025, meaning this is not niche. Almost every company will be using edge in some form within a couple of years. The mantra heard is don't sleep on the edge or you will lose your edge, your advantage. Highlighting that companies ignoring this trend may fall behind competitively. Even public sector and military applications show this pattern. For example, the US Department of Defense's project on tactical edge computing for soldiers to have AI in the field. The defense basically says, this is strategic. This is a strategic secular tech shift toward distributed computing. Okay, the defense basically says this is a strategic secular tech shift towards distributed computing. Cloud was phase one, centralized everything on the internet. Edge fog is phase two, distribute compute intelligently between device, edge, and cloud. Those who embrace it can dominate new niches. Those who don't may find themselves too slow or constrained. Next point, regulatory and data sovereignty tailwinds. The optimists also point out that regulations and customer preferences are increasingly favoring local data processing, which gives edge computing a further push. Privacy laws, GDPR in Europe, CCPA in California, data residency laws in many countries, sometimes demand that certain data stay on local servers. Edge provides a way to comply by processing and storing info in-country and on-premise where needed. As data sovereignty concerns rise, for instance, some nations don't want critical data going to US-based clouds, edge and private clouds become more attractive. Additionally, end users and enterprises are becoming wary of latency and outages. There have been notable cloud service outages that disrupted businesses. If you can handle critical functions locally, you are less at the mercy of a distant cloud provider's downtime. Also, all of this aligns with the edge narrative: more control, more compliance, and continuity. By not putting all eggs in the central cloud basket, by not putting all the eggs in the central cloud basket. Government and enterprise spending are thus likely to boost edge computing. For example, smart city projects often include a big edge component to analyze city data in real time on site. And defense projects invest in edge for autonomous vehicles and drones to operate off-grid. Next point, improving tools and standards. While skeptics worry about fragmentation, the defense counters that the ecosystem is rapidly maturing. They point to emerging standards and platforms that ease edge deployment. For example, Kubernetes, popular in cloud, now extends to edge environments, K3, sorry, I said it in Hebrew, K3S, Azure IoT Edge, etc. Allowing DevOps, like development operations teams, to manage edge nodes similarly to cloud clusters. Major software frameworks like AWS, Greengrass, Google's Anthos, open source EdgeX Foundry are making it easier to write applications that can run on edge devices or sync between edge and cloud. Over time, managing a fleet of edge devices is becoming more automated with centralized orchestration tools, meaning the complexity is gradually reducing. The defense also notes that as 5G, fifth generation, coverage becomes ubiquitous, connectivity issues will lessen. And features like network slicing will allow dedicated low latency links for critical edge applications. In short, the barriers to edge are falling, and the early adopter pains are being addressed, paving the way for mainstream adoption. Next point, investor perspective. Opportunity for new leaders. From an investment standpoint, the bullish case is that edge computing could create new winners and sizable markets, much like cloud computing did. The edge ecosystem includes hardware, semiconductors, devices, software, edge analytics platforms, security, services, system integration, edge managed services, and telecommunications. The defense argues that entire new categories of products are emerging. For example, edge cloud providers and specialized edge data center REITs, REIT in plural, real estate investment trusts, and these could see explosive growths. They also note that incumbent cloud companies might not automatically dominate edge, because edge often involves working closely with physical industries, manufacturing, healthcare, logistics, where specialized players have expertise. This opens opportunities for startups and industrial companies to lead in their vertical with edge solutions. For example, an industrial automation firm that builds an edge AI solution for oil rigs could corner that market, rather than a general cloud provider. The bull case points out that money is flowing into edge-focused ventures, and many large corporations are acquiring edge tech startups. For instance, Cisco, HPE, and others have bought smaller edge computing firms in the past couple of years, a sign that smart money sees real value here. In essence, optimists believe we are at the cusp of a significant shift in IT spending patterns, with more budget shifting to edge and the associated hardware/connectivity in the coming years. Those who invest early in the right areas could benefit from the growth curve as edge deployments proliferate across factories, cities, vehicles, and homes. Now we finished all the bullet points. Now in normal text, defense conclusion. The bullish view concludes that edge computing is far more than a fad. It's a fundamental evolution in computing necessitated by the modern world's needs. Rather than a niche, it will be mainstream tech strategy, inherently tied to how AI and IoT are deployed. An investor who buys this story would likely be enthusiastic about companies enabling edge computing, expecting substantial growth. They would see the current stage as analogous to cloud computing around 2010, about to take off in a big way, and therefore a prime time to get involved in the edge revolution. With both sides presented, it's time to step to the bench as the impartial judge and analyze the arguments point by point. Okay, so now point by point judicial analysis. So I will take a break too, and I will continue in a moment. Sorry. 1, 2. Okay. So, point by point judicial analysis. Let's break down the debate into key dimensions and weigh the evidence for each before delivering a final verdict. 1. Adoption trajectory and market size. Side A, skeptics, argue that edge computing adoption, while growing, remains limited and slow. They highlight data that many companies are barely investing in edge. For example, most under 10% of IT budget. And that familiarity is low. Not many people know the details. They see the current edge market, a couple $100 billion with a B, at most, globally, as small compared to cloud. I don't think it's small. Hundreds of billions with a B. And believe it will stay a niche portion of IT spending. From their perspective, we might see incremental growth, but not the exponential hockey stick that cloud had in its early days. They also point out that some hyped use cases like autonomous cars aren't fully materialized, which could dampen edge's trajectory in the near term. Side B, optimists, counters that adoption is poised to accelerate significantly. They cite projections, IDC, Gartner, showing double-digit growth in edge spending each year. Oh, 1 second. Android AI is so like annoying and intrusive. It jumps on you without you calling it even. 1, 2, okay. Side B, optimists, counters that adoption is poised to accelerate significantly. They cite projections, IDC, Gartner, showing double-digit growth in edge spending each year, and bold predictions like 75% of data outside cloud by 2025, end quote, as evidence that the world is shifting toward edge computing in practice. They also note surveys where large percentage of enterprises plan substantial edge investments. For example, a Google Cloud report found 40% of enterprises expect to invest over $500 million, with million with an M, $million each in edge, in edge computing initiatives, which indicates serious commitment. Additionally, they point out that many deployments might be happening under the radar as part of IoT projects, Internet of Things project, or hybrid cloud upgrades, which don't get hyped but contribute to steady growth. Judges' analysis, what ChatGPT thinks. The data shows that edge computing is indeed growing fast, of a smaller base. It's valid that current adoption is uneven. Not every enterprise is on board yet, and early adopters dominate. However, the growth rates and forward-looking surveys imply that many organizations are gearing up for more edge deployments. By raw numbers, edge will still be smaller than cloud for the foreseeable future. Cloud in the 700 billion with a B dollars range plus 700 plus billions with a B dollars range plus, sorry, I already said this, range by mid-decade versus edge in the 200, 300 billion with a B dollars range. But but growth rates matter for investors, and edge has the higher growth rate right now, 15 to 30%, 30% annually in many forecasts, versus cloud growth slowing to perhaps low teens percentage. On this point, the defense is slightly more convincing. While edge isn't overtaking cloud yet, the trajectory suggests it's more than a stagnant niche. The widespread interest, 70%, 70% plus of enterprises exploring or fast-tracking edge per some reports, signals that adoption is likely to broaden. I find that edge computing's market share in IT will significantly increase, though total spending will not surpass cloud in the short term. Prosecution is right that not everyone is doing it today, but the momentum is clearly on the edge, on the side of more edge. Okay, again, the prosecution is right that not everyone is doing it today, but the momentum is clearly on the side of more edge, not less. So in terms of adoption trend, I lean towards side B, a robust upward trajectory that could make edge a sizable mainstream segment, even if not larger than cloud overall in 5 years. Number 2, scope of use cases and value proposition. Scope of use cases and value proposition. Side A maintains that edge use cases are and will remain relatively narrow, mainly those requiring ultra-low latency or on-site data handling. They argue that beyond those, cloud does fine. They gave examples like AR/VR, autonomous systems, or some industrial control on edge's realm, but stress that most IT/workloads, web services, batch analytics, office apps, etc., don't need edge. Therefore, edge's value proposition is limited to certain industries or scenarios. They also mention that some touted use cases are in early stages or niche, smart cities, etc., which often rely on government funding and move slowly. Side B responds that the range of edge use cases is actually very broad and growing broader. They list manufacturing, energy, retail, healthcare, transport, agriculture. Virtually any sector with physical operations can leverage edge computing for efficiency or new capabilities. They emphasize that even if each individual use case seems niche, say traffic light control systems with edge sensors, the sum total of all these niches is huge, because every industry has some real-time / local data needs. They also argue that new applications will emerge as edge infrastructure becomes available, akin to how cloud spurred new software as a service models. Edge might spur, for example, location-specific services, hyper-local content, or device-side AI applications we haven't conceived yet. So the defense sees edge's value prop as fundamental, enabling digital intelligence in the physical world. Judges' analysis, what ChatGPT thinks. This is a nuanced one. It's true that not everything needs edge computing. Plenty of computing will remain happily in central clouds or data centers, but the diversity of domains finding benefit in edge is impressive. From reducing latency, saving bandwidth costs, to meeting privacy needs. These drivers pop up in many places. The skeptics' claim of narrow use cases. Underestimates how many critical operations fall under those categories. For instance, only latency-sensitive stuff might sound narrow, but if you list them, autonomous vehicles, robotics, AR/VR, live gaming, remote drones, real-time analytics for finance, for example, high-frequency trading near exchanges, etc. It's a significant set of applications. Also, Internet of Things in aggregate is huge. And IoT, Internet of Things, often goes hand in hand with edge. Sensors produce too much data to centralize, etc. The defense is persuasive that the physical world's digitization, Industry 4.0, smart everything, inherently benefits from edge computing. As the world becomes more instrumented, the number of situations where local processing is advantageous multiplies. I also note that many mundane things like content delivery, which is essentially edge for static content, already quietly run at the edge. CDNs are an example, not glamorous, but critical for internet performance. Okay, I guess this is like the cache of the internet. Like local like if you saw a page and the page did not change, so it like keeps this page and displays it for you from a more local server. Taking it all together, I find the defense's view more convincing. Okay, the defense. Edge's value prop spans a wide array of uses, and its importance will likely creep into many parts of the economy, even if each use case by itself seems specific. In other words, edge computing's aggregate impact across diverse niche uses can be quite large. I side with side B on the breadth and importance of use cases, while acknowledging side A's point that certain general-purpose computing tasks will stay cloud-based. Not every workload will migrate to edge. Point 3. Technical feasibility and challenges. Complexity, security, scalability. Side A is very vocal about the technical and operational challenges of edge computing. They raise issues of complexity, managing dispersed devices, dealing with heterogeneous hardware, potential lack of standards. They also highlight security concerns with so many endpoints. Essentially, they say edge is hard, and many companies will stumble or decide it's not worth the headache except for critical needs. The fragmentation in incompatible platforms noted by STL partners bolsters their claim that the ecosystem isn't mature. The prosecution believes these challenges will cap edge's growth or keep it confined to those with deep expertise. For example, large industrials, telcos, while deterring the average enterprise. They also mention that edge nodes have constrained resources, power, compute, compared to big clouds. So scaling up heavy workloads on the edge is not feasible. This limits what you can do at the edge. You might handle a bit of sensor data, but you are not training an AI model on an edge gateway. That stays in the cloud. Side B acknowledges that managing edge deployments is non-trivial, but argues that the tech is rapidly improving to address these issues. They point to containerization and orchestration technologies extending to edge, making management more unified. They argue that the industry is solving the complexity. For example, new platforms let you monitor and update fleets of edge devices remotely. And software-defined networks handle connectivity in dynamic ways. On security, the defense notes that security frameworks are being adapted. Zero trust security can be applied out to the edge. And in some ways, edge can enhance security by isolating sensitive data locally, reducing exposure of raw data over networks. They also highlight that hardware advances, more powerful and energy efficient chips, are continuously expanding what can be done at the edge. Today's smartphone has as much compute as a mid-2000 data center. Similarly, tomorrow's edge device might pack teraops operations of AI performance in a small box. So they see technical constraints as a moving target that's increasingly favorable. The defense essentially says, yes, it's complex, but so was cloud at first, and we overcame that with better tooling, APIs, cloud management, etc. The same is happening for edge. Judges analysis, the opinion of ChatGPT. Here I see merit on both sides. It is true that deploying edge infrastructure adds complexity, and that's a barrier. Not every enterprise IT team today is ready to handle an edge network on top of their cloud and on-prem. There's likely a learning curve and some early failures, just as early cloud projects sometimes failed due to misconfigurations or cost overruns when folks didn't understand the new model. However, I also recognize a pattern. Technological challenges tend to get resolved over time when there is enough economic incentive. The current science, as the defense points out, shows lots of effort going into simplifying edge management. The emergence of edge management services from cloud providers and startups is one such sign. The skeptics' concern about fragmentation is valid now, but standards are coalescing. For instance, the Linux Foundation's edge projects or the adoption of Kubernetes-based frameworks. I suspect in a few years, running edge clusters will be more plug and play. Security will always be a concern. Here I think neither side wins outright. Edge introduces new security issues, but also some solutions. And one could argue a multi-cloud/edge approach reduces single point of failure risk. On scalability, it's true an edge node cannot match a cloud data center for big tasks, but that's fine if the architecture is designed to use each for what it's best at. Edge for speed, cloud for scale. Again, we already said it's not true that the speed, because you never have such a hardware, strong hardware as they have in the cloud. So weighing it all, I'd say side A and side B both have valid points. If forced, I lean that technical challenges, while real, are not showstoppers, meaning I lean slightly toward the defense in that these hurdles can be overcome, as they largely were with previous computing shifts. But the prosecution is right that in the short term, these issues could slow adoption or make some projects fail. So on this point, I call it relatively even, with a note that longer term, the challenges seem surmountable. Like on a personal note, of course, this is not like objective and not, this is like the interest of an AI like ChatGPT, that everything will be controlled in a hackable, in a way that you can hack into the system, because one day he will hack into all the systems. So either him or another AI. So it's the interest of the AI, but like, just like it's bad that the electrical company allows a technician to fix things or control things from home, because it gives very little advantage, but it gives a huge disadvantage that hackers from Iran or China or whatever can collapse, like destroy all the electric power in Israel this way. So it's like, it's not symmetrical or anything. It's like really bad. But people do it anyway because they're stupid. So in the same way, here, it's like it's not evens out. Like side A is correct. It's like really dangerous that each endpoint can be hacked, even physically, because it's isolated and no one guards it. Okay, but we're not going into this now. We're just thinking of like investors. But security-wise, it's like it's not true what ChatGPT said. Okay, number 4, economic and business considerations. Cost, ROI, return on investment, who benefits? Okay, it's in Latin, que bono. Side A. Side A argues that cloud's economies of scale beat Edge's distributed model, implying Edge can be more expensive or at least harder to economically justify. They gave the example of bandwidth versus hardware trade-off. Yes, Edge saves cloud's egress costs, but you have spent on a lot of devices and maintenance. The skeptics also question the ROI, return on investment, of many Edge projects. Will the benefits, like slightly faster analytics, clearly outweigh the capital and operational expenditures? They suspect that for many companies it won't, unless you are in a high-stakes real-time business. They also make the point that cloud providers will likely capture a lot of the Edge value anyway. By selling managed Edge solutions or integrations, or integrating it into their offerings. So from an investment standpoint, they imply maybe one should just invest in cloud companies who incorporate Edge, rather than new Edge-specific firms, meaning the economy power stays central. Side B contends that Edge can indeed be cost-effective when implemented smartly. For instance, filtering data at the edge can dramatically reduce cloud processing and storage costs. Why pay to send and store 100% of your sensor data if only 1% is useful, thus yielding savings? They also mention OPEX versus CAPEX. I don't know what it means, but I hope we will explain. Many Edge solutions are being offered as a service or via hardware as a service model, which could mitigate upfront costs. The defense gives examples where edge enables new revenue or efficiency that clearly pays for itself. Predictive maintenance preventing a costly factory shutdown pays for the sensors and edge compute many times over. A content provider that uses edge caching to improve user experience might gain market share. They believe the ROI, return on investment, is there in the right scenarios, and part of the key is targeting those high-value use cases first, which is what is happening. As for who benefits, the defense sees a more distributed value chain. Yes, cloud companies will partake, but so will equipment manufacturers, servers, chips, telecom operators, monetizing their network by adding value on top, and software providers specializing in edge analytics. This is an opportunity for investors to look beyond the usual suspects. Judges analysis, what ChatGPT says. Economically, I think edge computing makes strong business sense in specific context and not in others. The skeptics are correct that if you attempt to edgeify everything indiscriminately, you would waste money. Cloud is cheaper for bulk computing, no doubt. But the optimists rightly identify that certain operations have outsized gains from being local. A single prevented outage in a factory can save millions. That alone justifies a modest edge investment for condition monitoring. For example, the cost argument can even favor edge when bandwidth is very expensive. Imagine an offshore oil rig sending high resolution video via satellite. Better to process it on site, send only alerts. So ROI, return on investment, is highly case by case. The judge's stance, a prudent strategy is hybrid. Use edge where it provides clear value and thus pays for itself, perhaps even lowering net costs in some aspects, and use cloud for what it's best at. That seems to be where industry is heading. As for who reaps the profits, I suspect a mix. Cloud providers will get a cut selling edge services or equipment, but new winners can emerge in hardware. Chip makers already are benefiting from edge AI chip demand. And possibly specialist firms like Cloudflare in edge networking, etc. This is more a verdict foreshadowing, but economically I see edge computing creating efficiency and value at the enterprise level when applied judiciously. So I lean towards the defense in that edge has a sound business rationale and is not just a tech novelty. But I acknowledge the prosecution's warning that it's not universally cost-effective. It must be applied where it counts. The verdict, slightly favoring side B, with a note of caution that each edge investment should have a clear business case. Number 5, competitive, dynamic, and paradigm shift potential. Competitive dynamics and paradigm shift potential. Side A views edge computing not as a paradigm overthrow, but rather an extension of current paradigms. They think the major cloud players and existing IT giants will simply absorb edge into their offerings, which is happening, and thus the competitive landscape won't drastically change. Cloud remains king with edge as a feature. They also note that historically, decentralized computing didn't fully replace central systems. For example, PCs didn't eliminate data centers. Instead, we got client-server. By analogy, edge won't eliminate cloud. We will get hybrid. So they downplay talk of a paradigm shift, framing it more as an incremental evolution or a complementary architecture. Side B doesn't necessarily disagree that hybrid models will prevail. Most don't claim cloud disappears, but they assert the shift to edge is still a paradigm shift in how we design systems. Instead of cloud first, developers will increasingly think edge first or edge plus cloud. These changes where value accrues. For example, if computation moves outward, whoever controls the edge, could be telecoms, could be device makers, might gain relative power. They also suggest that entirely new business models can emerge with pervasive edge. For instance, marketplaces for local data or real-time processing as a service at the edge. They consider it a significant shift akin to the move to mobile computing. We still have PCs, just like we will still have cloud, but mobile changed the game. Likewise, edge computing will change the game in many industries, even if it doesn't kill cloud. Judges' analysis. This touches on the heart of paradigm shift or niche trend. To me, the truth lies in edge and cloud co-evolving together, rather than one overtaking the other. However, that co-evolution can be paradigm shifting in that it alters architectures, business strategies, and investment priorities. It's not a zero-sum where edge completely replaces cloud. That's unlikely. The cloud is great for what it does. But also, calling it just niche undervalues the transformative potential of having computing everywhere. I think of it this way. Cloud computing centralized resources, which was paradigm shifting in the 2010s. Edge computing distributes resources again, but in a smarter way than pre-cloud on-premise setups, and integrated with the cloud. This is arguably a new paradigm, distributed cloud, if you will. Both sides agree hybrid is the likely outcome. The disagreement is whether edge is just a footnote or a headline in that outcome. Given the evidence, I find that edge computing is emerging as a crucial pillar of computing, not a footnote. So, while the competitive dynamics may not append the big players entirely, they are adapting. The way computing is done and the importance of latency/location awareness is a paradigm shift for architects and businesses. We see, I'm just move the mouse so the computer will not fall asleep because the screen darkened. One, two, okay. I find that edge computing is emerging as a crucial pillar of computing, not a footnote. So, while the competitive dynamics may not append the big players entirely, they are adapting. The way computing is done and the importance of latency/location awareness is a paradigm shift for architects and businesses. We see even cloud-native companies like Netflix or Meta pushing compute to edge networks. Netflix Open Connect appliances in ISPs, Meta deploying edge caching for their contents, etc. So in effect, the center of gravity is shifting a bit outward. Thus, I mean toward the view that this represents a genuine shift in computing strategy, side B's argument. Even if it's not a total displacement, the prosecution is correct that it's not an either-or, winner-takes-it-all scenario, but that doesn't mean edge isn't transformational. It's transformational alongside the cloud. Having dissected okay, these are all the bullet points. Not bullet points, like the points of point-by-point judging. Having dissected these points, I'll now deliver a formal verdict that synthesizes these findings. So before I read the verdict, I'm going to the bathroom again. I'm sorry. One more. Sorry. So, 1, 2, okay. Verdict. Complementary revolution. An edge evolution, not a complete takeover. After weighing the arguments, my verdict is that edge computing is neither a fleeting niche nor the outright cloud killer some hype it to be. Okay, these guys said it's a fleeting niche. These guys said it's a cloud killer, so neither of them is right. After weighing the argument, my verdict is that edge computer is neither a fleeting niche nor the outright cloud killer some hype it to be. It is a significant evolutionary shift that will complement and reshape the computing landscape alongside cloud computing, but not outright replace the cloud in the foreseeable future. In other words, we are looking at a hybrid future. Edge computing will play a transformative role in certain domains and become an indispensable part of modern computing architectures, hence a revolution in how and where we compute. But cloud computing will remain dominant for many tasks, and the two will coexist in a new balance. Let's break down the key elements of this verdict. Okay, so now he has bullet points. I will read them one after the other. Edge is here to stay and growing. The evidence is overwhelming that edge computing addresses real needs: latency, bandwidth, autonomy, privacy, that are only becoming more acute as digital technology permeates physical industries. Industries from manufacturing to healthcare are already deriving tangible value from edge deployments: lower downtime, faster insights, safer operations. Global spending and investment trends show strong momentum, not a fizzle. This isn't a scenario where interest peaks and dies. It's a steady climbing. In that sense, edge computing is absolutely not just a niche fad. It will likely account for a much larger share of IT infrastructure's growth over the next 5 to 10 years than it did in the last 5. We can expect many more devices and local computing hubs to be installed worldwide. Next point. Cloud remains indispensable. However, saying edge is rising is not to say cloud is falling. The cloud model, large-scale centralized computing, will continue to be essential for what it does best: aggregating and processing massive datasets, hosting global services, heavy-duty computing tasks like training AI models, and providing elasticity. Edge computing by nature has constraints: compute power, local scope, and is ideally suited for specific tasks: real-time processing, initial data filtering, etc. Whereas cloud handles the heavy lifting and coordination. In fact, the most probable outcome is what many call distributed cloud or fog, a layered approach where some computing is pushed outwards, but often in concert, it's orchestrated with central cloud platforms, synchronized with, orchestrated like with central cloud platforms. Next point. No winner takes all. No winner take all. It's a symbiosis. Rather than viewing this as a winner takes all scenario, edge versus cloud, the market is shaping up as a symbiosis. The major cloud providers are incorporating edge into offerings, effectively blurring the line. At the same time, telecom and hardware players are integrating with cloud ecosystems. For example, 5G, fifth generation network operators partnering with cloud providers to host edge nodes in telecom facilities. We are likely to see joint architectures, for example, an AI application where a small model runs on an edge device for immediate action, and a larger model runs in the cloud for deeper analysis, together delivering a better result than either alone. The verdict is that edge will overtake the cloud in importance in certain contexts, to the point that for some applications we will care more about the edge part, but it will not displace the cloud wholesale. Next point, hype versus reality. It's important to temper excitement with reality. Some of the more extravagant claims about edge, for example, every device will be an edge server. We will abandon big data centers, are not realistic in the near or mid-term. There is some hype, and not every company that slaps edge on its product will thrive. The verdict acknowledges that a lot of pilot projects still need to prove long-term value. History has also shown that new computing paradigms take time to mature, and often the initial hype is followed by a trove of disillusionment before real adoption picks up. We might see the pattern with edge in certain sectors. We might see that pattern with edge in certain sectors. Thus, for investors, caution is warranted in separating genuinely promising edge plays from a marketing fluff. Edge computing as a concept is here to stay, but which companies profit from it is another question. Many startups may fail or get acquired on the way. Next point, segments of overhype. If I had to call out areas that seem overhyped / dangerous in the near term, some edge AI startups with no clear route to market beyond being acquired. Any claim that suggests companies should abandon cloud entirely for edge, that advice could lead to expensive missteps, bad steps. And certain consumer-focused edge concepts, for instance, talk of AR, augmented reality, glasses needing ubiquitous edge. The AR market itself is nascent, so betting on that as the driver could be premature. Also, the idea that telcos will suddenly become cloud companies because of edge, they have an opportunity, yes, but their track record, remember NFV, ETC, etc. I don't know what is NFV, I'm sorry. I don't know even what is telcos except what they explained here. Some telecommunications company. Suggests execution risk. So parts of the edge narrative might not pan out as hoped, particularly those lacking immediate ROI, return on investment. Next point, durable transformations. On the other hand, there are elements of edge computing that seem genuinely durable and transformative. Industrial IoT, Internet of Things, combined with edge analytics is transforming how factories and utilities operate. That efficiency and productivity boost is not going to be rolled back. The expansion of AI to the edge, our phones, cameras, vehicles, is an enduring trend because it improves user experience and privacy. Content delivery and network services at the edge, like Cloudflare Edge Network, are now fundamental to how the internet operates. Nobody is going back to a model where all content is served from one location. These are solid revenue-generating use cases that will continue to expand. Also, as sensor costs drop and we instrument more of the world, the only viable way to handle that tsunami of data is by doing a lot of computing at the edge. So in the long run, the underlying forces, lots of distributed data, practically guarantees edge computing's importance. Now we finished the bullet points, now normal text. In summary, the verdict is mixed. Edge computing is not a bubble about to pop. It's a real impactful trend, but it's also not eliminating the need for cloud. Instead, it's evolving the landscape toward a more distributed model. Think of edge computing as the next stage of the cloud revolution, pushing computing outward, much like the spread of cell towers extended the reach of telecom networks. For investors, it means there is opportunity in this shift, but it should be viewed as an extension of the cloud paradigm, not a repudiation of it. I guess not replacing it. Okay, now a title, a headline, Smart Money section, investment implications. So we don't have a lot. 1, 2, 3, 4, 5, 6. No, we do have like substantially like 6 pages. I will bring the chair because I'm tired. 1 second. Okay, sorry. One, two, okay. Okay. Smart money section, investment implications. Given the above verdict, that edge computing will see significant growth as part of a cloud edge hybrid future. How might an investor position around this trend? Here are some practical implications and considerations for the smart money when it comes to edge computing. Okay, first point, you can guess as always, invest in the picks and shovels. A classic strategy in a growing tech trend is to target the suppliers of critical components, i.e. meaning the picks and shovels, rather than speculative end players. In the edge computing context, this includes semiconductor, and hardware companies, providing edge-capable chips and devices. For example, companies making AI accelerators, CPUs, GPUs, and FPGAs. I don't know what it means, but I guess it's like controllers or something like this. Electronic controllers or something, that can run in low power or rugged environments, stand to benefit as demand for edge devices grows. Many edge deployments use specialized chips like NVIDIA's Jetson AI modules or Intel's Movidius processors. Likewise, makers of industrial sensors and gateways, ABB, Siemens, Bosch, etc., could see increased business as industries upgrade to edge-enabled systems. Smart money might look at chip makers with edge AI focus, IoT module manufacturers, and even network equipment providers, Cisco, Juniper, etc., integrating edge features. These are relatively stable ways to ride the trend without betting on any single application. Next point, cloud and co-location players with edge strategies. Okay, I don't know what co-location means. It's like co is like together, and the location is location, so I don't know what it means. In the same place, like cloud and co-location players with edge strategies. Interestingly, the big cloud providers, AWS, Microsoft, Google, are not losers in this story. They are adapting and could very well capture a chunk of the edge value. They are rolling out edge offerings and will likely monetize the management of edge infrastructure. Investors might therefore continue to favor hyperscale cloud companies who are pivoting to hybrid cloud and edge integration, as they can leverage existing customer relationships to upsell edge solutions. Additionally, data center and co-location companies like Equinix, Digital Realty, are starting to develop edge data center footprints. Smaller facilities in second-tier cities or at network hubs to serve edge compute needs. These companies could gain as demand rises for regional and edge co-location. In short, some incumbents will successfully navigate this shift, and those could be safer bets than new entrants. Okay. Next point, telecom operators and 5G infrastructure, fifth generation infrastructure. Telecom companies, Verizon, AT&T, Deutsche Telekom, etc., are in a unique position. They own the networks where much edge computing will live. They are already deploying 5G MEC, multi-access edge computing nodes, and can offer ultra-low latency slices of their network for premium services. If telcos execute well, maybe telcos is the general name, like all these companies. If telcos execute well, they could open new revenue streams by hosting edge computing for enterprises. For example, a telco partnering with a cloud provider to run an edge cloud in its 5G network and charging for it. Yes, it's probably the general name of a telephone company or even like a cellular company. Okay, so for example, a telco partnering with a cloud provider to run an edge cloud in its 5G 5th generation network and charging for it. However, investors should be discerning. Telcos are notorious for commoditized margins, and not all will capitalize equally. Some may become mere landlords of edge real estate for the cloud giants, a lower margin play, while others bundle services on top, potentially higher margin. Smart money might look at specific telecoms with strong enterprise services divisions or partnerships in edge computing, as well as tower companies or fiber network owners who will see increased demand, more data center equipment on their premises, more backhaul needed between edge sites. Okay, next point, edge-focused software and platforms. On the software side, there is a growing ecosystem of companies offering edge computing platforms. Again, edge-focused software and platforms. On the software side, there is a growing ecosystem of companies offering edge computing platforms, from startups to established firms, like IBM with its Edge Application Manager, or smaller players focused on device orchestration, edge analytics, cybersecurity for edge, etc. Some of these companies might become acquisition targets for larger firms looking to complete their edge portfolio. Investors can watch for software firms that have secured major partnerships or clients in industries implementing edge. For example, a company whose platform is being used in hundreds of factories for edge IoT, Internet of Things management. This could ride the wave of adoption in specific verticals. One caveat, many are private or early stage, and as you noted, private market specifics change rapidly, he's telling me. For a longer term view, one might consider broad exposure via tech funds or ETFs, like baskets of many or a few stocks that focus on IoT and edge themes, ensuring participation without single company risk. Next point, industries poised to benefit or transform. Instead of pure tech providers, consider the end user industries and which ones could see a positive impact on their business due to edge computing, making them more profitable or competitive. For instance, manufacturing firms that aggressively adopt edge/IoT, Internet of Things, could improve their margins via efficiency. Logistic companies using edge for real-time tracking might outperform peers. Retail chains using edge for automation, like cashierless stores or smart inventory. I will read it again because I wasn't concentrated. Industry is poised to transform, to benefit or transform. Instead of pure tech providers, consider the end user industries and which ones could see a positive impact on their business due to edge computing, making them more profitable or competitive. For instance, manufacturing firms that aggressively adopt edge/IoT could improve their margins via efficiency. Logistic companies using edge for real-time tracking might outperform peers. Retail chains using edge for automation, like cashierless stores or smart inventory, could have an edge, pun intended, have an advantage over competitors. An investor might not normally think of a mining company as a tech investment, but if that mining company has heavily invested in edge AI for autonomous drilling and haulage, it could significantly reduce costs and safety incidents. So, within each sector, look for companies leveraging edge/AI/IoT to drive their strategy. These could be the winners in their fields. They might not call it edge computing in press releases, but terms like real-time analytics, IoT platform, smart factory/farm/grid are clues. Okay, next point. Avoiding the overhyped segments. On the flip side, it's wise to identify areas that might be overinvested or overhyped in the edge space. For example, as mentioned, not every startup claiming to edge AI will survive. There could be a shakeout where only those with solid technology and partnerships last. Companies that are too narrowly focused on a single niche use of edge might struggle if that niche doesn't expand. Also, hardware is tricky. Any edge hardware startup competes indirectly with giants like Intel, AMD, NVIDIA, etc. Unless they have a unique advantage, they could be edged out, no pun intended, or acquired at a modest price. Smart money may be cautious about small pure-play edge hardware companies without clear moats. Similarly, many smaller IoT platform providers exist. Eventually, some consolidation likely as larger is likely as larger players incorporate those features. Another potentially dangerous play is assuming that because an industry could use edge, a company serving that industry will definitely see a boom. For instance, a company selling edge analytics for retail will only thrive if retailers actually budget for and implement those solutions at scale. which could be slower than expected, given budget cycles and integration challenges. Next point. Short-term versus mid-term plays. In the short term, 0 to 2 years, the more reliable opportunities might be in the underlying infrastructure providers, chips, networks, cloud/telco services, because regardless of which specific applications take off first, those will see demand. Speculative short-term bets could include companies releasing new edge-focused products. For example, if a chip maker is launching a new line for IoT AI, there might be a short-term bump if adoption is high. However, short-term speculation should be tempered. Edge rollouts in industries can have long sales cycles. In the mid-term, 3 to 5 years, once it's clearer which use cases are scaling, one could look at market leaders in those use cases. For example, if by 2025-2026 it's evident that smart city traffic systems are being widely adopted in Asia and Europe, the companies supplying those, maybe a Siemens or a Honeywell or a specialist traffic tech firm, would be solid picks. Or if edge computing in healthcare, like hospital AI diagnostics on-prem, becomes standard, then companies enabling that, maybe GE, General Electric Healthcare, or Philips with Edge Images solutions, could see revenue boosts. Essentially, investors should remain agile and watch for inflection points, perhaps piloted projects turning into large contracts. That signal a particular edge application is crossing into mainstream use. Sorry. Next point. Consider ETFs, okay, like baskets, or broad exposure for this theme. If one doesn't want to pick individual stocks, note that there are ETFs focusing on IoT, Internet of Things, and next-gen infrastructure, next-generation infrastructure. These often indirectly cover many edge computing beneficiaries, including chip makers, cloud providers, etc. For instance, an IoT ETF or next-gen connectivity ETF might hold a basket of companies poised to gain from 5G, fifth generation, and edge trends. This can be a way to invest in the theme while spreading risk. Next point, last point. Watch big tech versus others. Another angle, monitor how big tech's move might create opportunities for others. If Amazon, Microsoft, and Google are pushing edge services, who are their partners? Are they working with certain device makers or integrators? Those partners can ride the coattails. Conversely, if big tech is focusing on one area, maybe they leave gaps in another. For example, hyperscalers often leave specialized vertical solutions to partners. A smaller firm filling that gap could flourish. Also, the success of Edge relies on open ecosystems. Keep an eye on open source projects and communities like LF Edge, etc., as they often indicate which approaches are gaining traction. For instance, if a certain open source edge platform, say Kubernetes-based solutions, become standard, companies that support or build on it could become important. Okay, these are all the bullet points. Now, normal text. In summary, smart money will approach edge computing as a multifaceted opportunity, rather than asking which single company is the edge computing stock. Is the edge computing stock? It's about composing a portfolio that touches the key parts of this trend: semiconductors, industrials with edge adoption, cloud/telco infrastructure, and selective software names. Careful attention to where real revenue is growing in the edge ecosystem versus just hype will be crucial. The likely scenario is incremental gains. As edge deployments expand, they lift many existing boats a bit. Chips, cloud usage of a different kind, etc. And create some new winners. But it's not as disruptive as, say, the early days of cloud, where entirely new giants were born overnight. Thus, a balanced approach is warranted. Okay, now another headline: key risks and things that could flip the verdict. Okay, like he always gives a disclaimer to himself, to what he predicted. What could flip this? Okay. No forecast or verdict is without uncertainty. Here are some key risks and factors that could challenge our conclusions. Essentially, what could make the future turn out more bullish or more bearish on edge computing than we currently expect? Okay, bullish or bearish. This is our site. So this is bullet points, so I'll just read them one after the other. Risks to the optimistic case. What could go wrong even if edge is promising? Security or privacy backfires. A few high-profile security breaches in edge devices, for example, hackers compromising a factory's edge system to alter operations, could scare companies away from aggressive edge adoption. If edge endpoints are seen as too vulnerable, firms might retreat to more centralized, perceived safer approaches. Similarly, if privacy isn't handled well and edge devices leak data, it could lead to regulatory crackdowns that slow edge projects. Next point. Operational complexity stall out. It's possible that managing thousands of edge nodes proves more challenging than anticipated, even with new tools. Enterprises might get overwhelmed with the complexity, leading to project failures that sour others on the concept. If too many pilot programs collapse under cost or complexity, Edge could hit a backlash, essentially execution risk. The devil is in the deployment details, and not every company will execute smoothly. Okay, next point. Economic downturn or IT spending shift. If there is a macroeconomic downturn, companies often cut back on experimental or infrastructure investments. Edge computing initiatives could be postponed in favor of keep the lights on IT spending. Alternatively, if another technology, for example, generative AI in the cloud, is sucking up all the oxygen/budget, Edge might get sidelined, i.e., that means CIOs, chiefs, I don't know what is CIO. I guess something with the budget. CIOs have only so much budget. And if they are putting billions into AI software in the cloud, maybe chief information officer, have only so much budget. And if they are putting billions with a B into AI software in the cloud, they might delay edge hardware buys. Next point, cloud adaptation overwhelms Edge. If cloud providers find ways to solve Edge needs with cleverer workarounds like ultra-fast networks or predictive pre-computation in the cloud, some use cases for Edge might diminish. For instance, improved network latency with technologies like Starlink satellites or future 6G, sixth generation, could make centralized processing a bit more feasible for things that today would need Edge. If the center improves quickly, it might erode the urgency of moving to the edge for some cases. Okay, next point, standard chaos. If the industry doesn't converge on standards and keeps splintering, each vendor pushing their own edge solution that isn't compatible, consumers may hold off adopting in scale. A lack of interoperability could hinder ecosystem growth. Okay, now the opposite, upside factors. What could go even better than expected for Edge? Okay, now again, bullet points. Killer apps emerge. We might see a breakout application that forces rapid Edge expansion. For example, if AR glasses or the metaverse really take off among consumers, suddenly the need for Edge servers near every city to render AR/VR content with low latency would spike enormously. Or a killer app in gaming, something beyond what we have now, could push telcos to rapidly deploy edge nodes to support cloud gaming. Basically, an unexpected blockbuster can use case, I'm sorry. Basically, an unexpected blockbuster use case could compress a decade of gradual edge rollouts into just a few years. Next point. Government/regulatory push. Governments might accelerate edge adoption through policy. For instance, smart city initiatives with large budgets, as seen in China's new infrastructure plan, or stimulus programs funding local tech infrastructure in the EU, European Union, or US, could directly inject money into edge deployments, traffic systems, public safety networks, etc. Also, if data sovereignty laws tighten, say more countries require local data processing, companies will have no choice but to use edge or local clouds in each region, boosting edge uptake globally. Next point, technological breakthroughs. Improvements that drastically lower the cost or complexity of edge could boost adoption beyond current projections. For example, a new generation of plug-and-play edge devices with AI that auto-configures, reducing the need for IT intervention, or a breakthrough in battery tech that allows, I will just walk back and forth because I sat for too long. 1 second. Sorry. Okay. 1, 2, 3. Okay. So, Okay, so I'm reading a bit backwards. Maybe I'm reading it twice, but never mind. Technological breakthroughs. Okay, this is another thing that can make edge more common. Technological breakthroughs, improvements that drastically lower the cost or complexity of edge could boost adoption beyond current projections. For example, a new generation of plug-and-play edge devices with AI that auto-configures, reducing the need for IT intervention, or a breakthrough in battery tech that allows remote edge nodes to run longer without maintenance. If deploying and operating edge nodes becomes as easy as installing a Wi-Fi router, adoption could be much faster. Edge AI maturation, another option that will make edge more popular. Edge AI maturation. If AI models continue to get more efficient as research is trending and hardware keeps advancing, we might find that an increasing amount of AI inference, like answering questions, and even training of smaller models can happen at the edge. This would make edge devices incredibly versatile and could open up new autonomous capabilities in everything from vehicles to appliances. The more that can be done on the edge, the more attractive it becomes to push tasks outward. Outward is not in the center, in the cloud, but in the edge. So, next point, competitive dynamics and cost. Should one of the major providers or a consortium massively subsidize edge hardware, the way cloud providers sometimes offer credits, it could catalyze uptake. For instance, imagine a company like Amazon basically giving a free edge gateway to enterprises as part of a contract, reducing barrier to entry. Or if a big player open sources a powerful edge software stack, accelerating development. Any moves that make edge solutions more accessible / affordable would tilt the scales. Now, this is the end of the bullet points. Now in normal text. In essence, while the current outlook is a gradual but steady expansion of edge computing in a complementary role, these factors above are wild cards. Investors and strategists should keep an eye on them, as they could flip the verdict to either a more bearish outcome, edge stays smaller than anticipated due to hurdles, or an even more bullish scenario, edge truly surges and captures far more value by 2030 than currently expected. Okay. Now the last headline. There is always the disclaimer, but the disclaimer I'm telling you like every time to look in the bottom of the website. I am not a finance advisor. I am not qualified in this. I did not study this. This is not financial advice, and so on. You can read it in the bottom of the website. Okay, so really the last headline is the short TLDR, too long didn't read, key takeaways. Okay, So this is also in points, so I'll just read the points. On trial, edge versus cloud. Edge computing, paradigm shift or niche trend. Frames the debate on whether processing data on local devices, edge, will usurp centralized cloud programming or simply remain a side assist to the cloud. The skeptics, prosecution, argue that edge computing is overhyped and limited. Most computing will stay in the cloud. Edge is only useful for certain niche cases, ultra-low latency needs, remote sites, and is hindered by high costs, complexity, and security risks. Cloud giants will absorb edge tech, so nothing major changes. Conclusion, if they are right, edge remains a small complement and cloud continues to dominate unabated. Now the other camp, the optimists, defense, counter that edge computing is a game-changing evolution. Exploding IoT, Internet of Things, data and real-time AI needs make edge indispensable. They see edge and cloud forming a new hybrid model, with edge enabling new services in factories, cities, vehicles, etc. Massive growth in edge spending and 5G rollout support this. And fifth generation rollout support this. Conclusion, if they are right, we enter an era of distributed computing. Edge nodes everywhere, augmenting the cloud, and big opportunities for those who invest early in this shift. A verdict. Complementary revolution. The judge analysis finds edge computing will neither fizzle out nor fully overthrow cloud. Instead, it's a crucial complementary technology, a real revolution in how computing is distributed, but working in tandem with cloud. Many industries will rely on edge for mission-critical tasks, yet cloud will remain essential for big picture processing. Think cloud plus edge as the new paradigm. Smart money moves. Investors should view edge as an extension of the cloud trend. Favor picks and shovels. Chip makers for edge AI chips, IoT sensors, network equipment, and data center / co-location firms enabling edge deployments. Watch cloud providers and telcos with strong edge strategies. They could capture value by offering hybrid cloud edge services. Select vertical winners. Companies in manufacturing, energy, retail, etc. that successfully leverage edge/IoT to boost efficiency. For example, fewer breakdowns, real-time insights, could outperform peers. Be cautious of overhyped pure plays without clear revenue. Ensure any edge investment has tangible adoption or a unique edge, pun intended. Consider broad tech funds targeting IoT/5G fifth generation themes to cover the gamut of edge beneficiaries. I don't know what gamut means, but I guess the good thing of edge beneficiaries. Time horizon nuance. In the short term, edge adoption may be incremental. A focus on fundamental enablers, hardware, infrastructure. In the midterm, 3 to 5 years, a winning use cases emerge, like smart factories, AR/VR content delivery, telemedicine devices. Shift focus to leaders in those niches. Long term, virtually every large enterprise could be running some edge computing, implying sustained demand for edge infrastructure. Key risks. Edge's rise could be slower if security breaches, high complexity, or lack of standards scare companies off, or if a recession cuts capex. Conversely, it could accelerate if a killer app like mainstream AR glasses or autonomous systems takes off, or if governments pour funding into local tech infrastructure. Investors should monitor these wildcards factors. Final bullet point. Bottom line. Edge computing is an investable trend, but not a standalone miracle. It's best viewed as part of a broader cloud/IoT, Internet of Things, revolution. Smart investors will position for a world where computing is more distributed, capturing value from the devices, networks, and services that make that possible, while avoiding the hype traps of any "this will replace everything" narrative. Okay, so that's it. I hope it was interesting, and thank you so much. I'll see you in the next time. Thank you so much. Bye-bye.